let's continue with the rest of the alkylating agents, and this compound is called busulfan. Okay. هلا, is it electrophilic? Looking at its structure, is it electrophilic? Yes. Two electrophilic sites. بمعنى إنه it can cross the DNA. طب what is the electrophilic atom in this compound? بالضبط. So this carbon in here, بالضبط. This carbon in here and this one in here are the electrophilic sites. طيب, why are they electrophilic? Because of the electron withdrawal effect, let's say, of this group, واللي احنا ايش بنسميها؟ Sulfonate. That sulfonate is a highly electron withdrawing group, all right? That is why this bond is highly polarized. And add to that, the electron withdrawal effect from those atoms and the sulfur will render this bond very weak, and the leaving group, which is the sulfonated group, is a very, very good leaving group, okay? هلا, if it leaves, this is what will result. Why is it a good leaving group? Why is it a stable leaving group? Is the negative charge on the oxygen localized? لا, it's not localized لأنه it can resonate, let's say, with those two pi systems. That is why, let's say, this oxygen or the negative charge developed on the oxygen here in the sulfonate, when it leaves, is highly stabilized, which makes this bond very weak, can be easily broken, rendering this carbon electrophilic, or in other words, bearing a partial positive charge. بمعنى أنها راح تكون subject to attack by nucleophilic, let's say, nucleic bases, in particular nitrogen number 7 in guanine, the most common, let's say, alkylating, or the most common atom or group that is alkylated in DNA. All right? طيب. هلا, this attack, when the nitrogen attacks this carbon, and at the same time this bond is broken and this group leaves, what is this reaction? ايش بعتبره? Elimination, addition, substitution. Addition يعني أنا ضفت إشي على الكربون، بس هاي الكربون طبعا don't forget إنه I have here still 2 hydrogens. When this nitrogen adds to the carbon, في إشي عم بينكسر مقابلها.
هو SN2 reaction.
Yes, it's a substitution reaction. In particular, it's called the nucleophilic substitution because they have this nitrogen acting as a nucleophile, attacking this carbon. And because the leaving of this group happens at the same time when this nitrogen attacks, that is why this specific substitution reaction follows the mechanism SN2, or nucleophilic substitution with the kinetic order of 2. Okay? طيب. هلا, busulfan, can you relate the name to the structure? Bu? No. Bi. لو إن had 2 bi. Bu is, let's say, taken, you think from what? Butyl. All right? The link in here, ما بين 2 sulfonates, is composed of 4 carbons. All right? So the linker is composed of 4 carbons, thus butyl or butane. Okay? With sulf, because I have a sulfonated groups. Okay? Now, again, when that nitrogen attacks this carbon, what happens is simply alkylation of nitrogen number 7. That is why it would be, or bearing a positive charge. And because I still have another electrophilic site, this carbon will be subject to attack from another nucleophilic nitrogen, thus leading eventually to cross-linking. Okay? طيب. نحكي عن الدكاربازين والبروكاربازين. By the way, those 2 drugs موجودين بعد السيسبلاتين والmethylating agents, بس لأنهم involves methylation أو alkylation of DNA، فعشان هيك أنا بعمل لهم shifting وخليهم ورح نحكي عنهم قبل ما نحكي عن methylating agents such as السيسبلاتين والكربوبلاتين. Okay? طيب. Decarbazine, procarbazine, zine to indicate what, or as a. because I have nitrogens in this compound. Okay, هلا رح نحكي عن the mechanism via which the carbazine eventually generates the alkylating agent. All right. البروكاربازين eventually بيعطيني نفس الالكيليتنج ايجنت بس بميكانيزم مختلف. رح افرجيكم اياها بس هاي مش مطلوبه منكم. احنا فقط رح نناقش الميكانيزم via which the carbazine will give rise eventually to the alkylating agent. So I will draw it here and then we will look at the exact, let's say, steps which are organized or drawn, let's say, much nicer. بعدين بدي افرجيكم البروكاربازين. اوكي. هلا to understand او احيانا الميكانيزم حتى احفظها هيك بطريقه اسهل اذا عرفت انا اول ستيب this may give me eventually the خلينا نحكي the او hints انه انا كيف ممكن اكمل. اوكي. هلا regarding the carbazine اول ستيب بتصير عليه which eventually will lead to its decomposition حتى يعطيني الالكيليتنج agent is simply hydroxylation of the alpha carbon. Okay, this is a very common metabolic pathways for nitrogen-containing compounds. In the carbon that are attached to nitrogens, especially if they are methyl, those carbons which we call alpha carbons, the hydrogens اللي عليهم can be easily, let's say, substituted with hydroxyl. فأول step راح تصير عندي for the carbazine. خليني أحكي عن أو let's say refer to the entire structure in here as R. عشان أسهل الرسم. I have here CH3 وفي حالة الديكاربازين by the way R is methyl. Again, the first step that happens is hydroxylation. One of the hydrogens will be substituted with a hydroxyl. Okay? كلنا بنعرف إنه if you have an sp3 hybridized carbon with two heteroatoms attached to it via single bonds, such a compound is not stable. It will tend to decompose very quickly, okay? Knowing that, you can easily then say in one of the lone pairs on the oxygen will form a double bond ومقابل هاي الباند اللي راح تتكون راح ينكسر إشي مقابلها because the carbon cannot tolerate 5 bonds. It can only attach via 4 bonds. مقابل هاي الباند اللي بدها تنكسر أو آسف اللي بدها تتكون. What is the weakest bond that can then break easier or very easy? This one, the carbon-nitrogen bond. Okay? هلا ممكن إنه in one step أحكي إنه مثلاً electrons will reside on the nitrogen, but actually because I have a pi system in here, this is what will happen. Okay? بمعنى إنه this entire part in here left as carbon. هلا صار في عندي double bond مع الأكسجين وستيل هاي الكربون مرتبطة ب 2 hydrogens. The other product اللي بيتكون nitrogen, okay, CH3. هلا صار في عندي a double bond between خلينا نرقمهم 1 2 3 nitrogen 1 nitrogen 2, okay, and nitrogen 3 now it has a single bond. Okay. دائما again زي ما حكيت لكم لما ناقشنا بالنيتروزيورياز, whenever you have 2 nitrogens or a diazine, this diazine can easily break into nitrogen gas ويصير في عندي decomposition of the bonds that are connected to it. What happens is here the lone pair on the nitrogen will form a double bond وراح تنكسر النيتروجين bond. Nitrogen. This compound is called methyl diazonium. Methyl diazine, and because it's positively charged, it's methyl diazonium. This compound can then easily break where you would have, let's say, CH3 plus, a methyl carbocation, and 2 gas. Okay? If you know or if you memorize that the mechanism first starts with hydroxylation of this one, then it would be easy for you to understand إنه بصير في عندك decomposition سريع a diazine eventually أو يعني مجرد ما إني أعرف إنه definitely راح يتكون عندي an N2 gas, then you can easily move the electrons. Okay? Does this compound alkylate DNA? For sure, because it generates a carbocation. Okay? But does it cross-link DNA? لا, because it has one electrophilic site. تمام? هلا again, for procarbazine, the mechanism that eventually leads to the alkylation of DNA is different. بس بدي أفرجيكم إياها. All right? First, what happens first is oxidation. يعني don't worry about that. What I need you just to know إنه في حالة procarbazine, also this compound will eventually generate a methyl diazonium, which will break into N2 gas and CH3+, or in other words, a methyl cation. So the products for both compounds are the same. Okay? Any questions so far? لا ما بصير cross linking. Because to cross link a DNA, an alkylating agent must have 2 electrophilic sites. This one has only 1. ننتقل هلا نحكي عن the platinum based drugs. So I will tell you, let's say من وين اجت هاي, let's say, or this the first methylating drugs or the first platinum based anti-cancer. What I will mention here أكيد مش مطلوب منكم في الامتحان. هلا كانت هاي based على ايش؟ على experiment, let's say done by this scientist, انه كان بده يشوف ال effect of electrical current على the growth of bacteria وin particular ال E. coli. فالاكسبيرمنت اللي عملها ببساطه E. coli ب let's say growth media, وكانت بهاي الجروث ميديا امونيوم كلورايد وحط فيها 2 electrodes of platinum. هلا when he ran the electrical current, eventually الاكسبيرمنت as expected انه ما بصير في عندي growth للبكتيريا. أو in other words, that electrical current inhibited the growth of bacteria. هلا later on the studies اللي صارت على هاي experiment later found out إنه actually it's not the electrical current that prevented cells from growing or from multiplying. اللي صار إنه البلاتينم رودز أو البلاتينم metal اتفاعل مع الأمونيوم كلورايد 2 equivalents of ammonium chloride and gave rise to this compound اللي هو cisplatin, or what we call a cisplatin. Okay, these are, let's say, the sources of ammonium, or those came from ammonium chloride. They coordinated with platinum, giving rise to this compound. Okay, راح نحكي later on ليش احنا بنحكي cisplatin, because for sure I have a transplatin, وراح نشرح ليش كمان انه why, for instance, the transplatin is inactive while cisplatin is. طيب, how cisplatin acts? Now, when this compound is administered and it crosses the the cell membrane, when inside the cell or even outside, okay, what happens is the process of aquation. Or in other words, this compound will interact مع الwater. راح يصير في replacements of the chlorides by water molecules. Cisplatin as it is, it's a neutral. It doesn't bear any charge. لكن when the chlorides are replaced by water molecules, as you can see in this compound or in this bioactive form of cisplatin, راح يصير في عندي 2 أو a charge of 2+. Well, this compound, in terms of its reaction with DNA, is way much faster than cisplatin itself. So actually, what experiments have shown, it's the aquated form of cisplatin is the one that interacts with DNA. Okay? طيب, what is the charge on DNA, on the outside of the DNA? Minus, because of the deprotonated phosphatic groups. And this one, positive, okay? هلا being equated or having a positive charge معناها إنه ببساطة, okay, اللي راح يصير an ionic interaction, يعني this aids in the approach of the drug to the DNA حتى إنه يتفاعل معه. وبرضه كمان those, let's say, amino group in here they can form hydrogen bond interactions مع DNA, which will further stabilize the complex ما بين this drug and DNA. Okay, so that is why these are very important structural features. رح نحكي عنهم بس نناقش ال structure activity relationship of cisplatin. هلا المشكلة في السيسبلاتين إنه let's say very reactive. This equated form is very reactive. يعني تقريبا خلينا نحكي almost 98% of the dose gets inactivated. The therapeutic effect of cisplatin بيرجع ل 2% only of the dose that is able to reach the DNA and interact with it. معظمه بصير له ايش؟ interaction with any nucleophile موجود عندي في السيل such as مثلا الجلوتاثيون such as النيوكليوفيليك residues اللي موجوده في let's say inside the cells. برضه كمان بصير في عندي equation outside of the cell طبعا بدرجه اقل وهلا بحكي ليش. و this equated form extracellularly is also inactivated because it can interact with serum albumin and other let's say proteins موجودين في bloodstream. Okay, only a small fraction of the drug reaches the DNA and eventually interacts with the DNA. Okay, لكن still high small fraction is let's say enough for its anti-cancer activity. هلا ال substitution of the chlorides with water molecules بتصير عندي inside the cell بدرجة كثير أكثر مقارنة بextracellularly. لأنه ال concentration of chlorides outside of the cell is way much more than those in the inside. فعشان هيك highly processed, the rate of that process is much faster inside of the cell versus outside of the cell. Okay? هلا شو بيصير؟ When the equated form approaches the DNA, as I have mentioned, that positive charge formed on the equated form of cisplatin is, let's say, aids in the attraction اللي بيصير ما بين equated form وال DNA. النيوكليوفيليك species اللي موجودة عندي في DNA can attack the platinum, substituting the water, okay, and forming a bond ما بين مع البلاتينم. هاي البوند مع الترانزيشن ميتالز احنا شو بنسميها؟ A coordination bond, which is a type of a covalent bond تقريبا in يعني بstrength الcovalent bond. Okay? هلا because I have two chloride sites that can be equated and interact with the nucleic bases, can cisplatin cross-link the DNA? Yes, it can. It's because both of those, let's say, electrophilic sites or both of those, let's say, leaving groups مرتبطين بنفس البلاتينم أو بنفس الآتم. فيوجوالي الكروس لينكينج اللي بصير عندي على نفس الستراند أو ما بين النيوكليك بيسز بتكون جدا 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 قريبة من بعض. Okay? Because as if you have the two leaving groups مرتبطين على نفس الآتم. فthat is why بصير في عندي cross linking و mostly intra-strand cross-linking. هلا because of the two electrophilic sites being very close أو both attached to the same atom اللي بصير في عندي besides طبعا as if you are alkylating the DNA بصير في عندي kink بال DNA structure. And what we mean by kink إنه هاي two أو البلاتينم وكأنه يعني it bends the DNA. Okay, which will make it, let's say, for sure, besides طبعا stabling, as if stabling the DNA, بصير في عندي minor groove major groove بتتسع المسافة ما بيناتهم أكثر وأكثر, which will make it, let's say, subject to attack by many, let's say, enzymes موجودين عندي في النيوكلياي. Okay? Here's a crystal structure of DNA that is bound to cisplatin. This blue sphere that you see in here represents the platinum. This one in here is ammonia. طبعا the hydrogens are removed in this crystal structure بس عشان هيك to clarify the structure. Definitely you know that we have, let's say, hydrogens in here. Okay, and as you can see, the platinum is forming covalent bonds or coordination bonds with, let's say, two consecutive guanines on the same strand. Okay, here are, let's say, two representations of where you have platinum forming a coordination bond with nitrogen number 7 in one guanine and nitrogen number 7 in another, let's say, guanine. Or in some cases, guanine adenosine. بس لاحظوا انه بتكون عندي البيس pairs are on the same strand. هلا ليش ما بيعمل inter-strand cross-linking? Can you think of, let's say, why or an answer to that? Exactly, because if one, for instance, was able to coordinate with one base, راح تكون, if I am, let's say, imagining, or if I would be considering, sorry, وكأنه let's say this is the other strand, راح تكون ال other nucleic base far away from platinum حتى يصير في عندي cross linking. So that is why for, or in the case of cisplatin, what we see is inter-strand cross linking. تمام؟ طيب. هلا based على اللي حكيناه, okay, I need you to think of some features about the pharmacophoric features of the pharmacophoric necessities for the platinum compounds. شو لازم يكون موجود فيهم برأيكم؟ For sure. What else? Amine. Yes, definitely. هل ممكن أنا أعمل alkylation للأمينز برأيكم؟ يعني بجوز إشي أنا ذكرته في البداية بس ما رجعت وعدته هون يعني it probably is not seen let's say in those structures. لكن الأمينز with those hydrogens in here, those will form hydrogen bond interactions with any, let's say, hydrogen bond donor or acceptor موجود حواليها, which will even further stabilize the interaction ما بين cisplatin with DNA. For those, or this group is very important for the stability of cisplatin DNA structure. Otherwise, لو أنا شلت الأمينز على الأغلب حتى مع الكوردينيشن بانز still ما بيكون هالكومبلكس كثير ستيبل، يعني ممكن يربط ويرجع let's say ينفصل السيسبلاتين. Okay, so based on that, can I alkylate in nitrogen? ممكن هو، بس at least I need to leave at least one hydrogen. Okay, to make that compound or that, let's say, nitrogen or alkylated nitrogen able to form hydrogen bonding. طيب, what else? Two leaving groups, exactly. هل ممكن طبعا ال leaving groups here are the chlorides and they leave as Cl-. هل ممكن أبدل الكلورايد with something else? Yes, yeah, 100%. Definitely I can substitute it with other leaving groups. لكن in terms of how good that leaving group relative to the chloride, okay, إذا كانت very good leaving group معناها راح تكون هاي الباند ضعيفة بينها وبين البلاتينا، ممكن أي شيء يكسرها. Which means إنه I will not give this compound enough time إنه يوصل ال DNA. Okay. ف even though experimentally إذا أنا حطيت هون a very good leaving group, it will be more active in vitro, لكن in vivo راح تتكسر قبل ما توصل ال DNA. Okay. لكن إذا كانت مثلا الجروب is a bad leaving group, ممكن انها تكون البوند بينها وبين البلاتينم very strong، ما راح يصير لها equation. اوكي، احنا السيسبلاتين بنعتبره a pro drug لانه it's not by itself is the one interacting مع الدي ان اي، وانما لازم يصير له equation. يعني in other words لازم يصير له bioactivation before binding to the DNA. يعني in other words I need a moderate leaving group، لا هي very strong ولا هي very weak. اوكي. طيب، what is the geometry around the platinum زي ما هو مرسوم هون؟ No, the entire geometry of the molecule. يعني أنا لو بدي أرسم مثلا شكل based على هاي الاتومز وكيف مرتبطة. يعني تخيل البلاتينم وأنا في عندي أمين كلورايد وكأنهم طالعين من let's say the plane of the slide، وفي عندي two groups as if they are coming out. Are they planar؟ هل كل هاي الاتومز planar برأيكم؟ Yes, they are actually planar, okay? Because they form what looks like a square. The geometry around platinum is actually square planar. يعني كل الاتومز الامينز البلاتينم الكلورايدز كلياتهم على نفس البلين. All of them are on the same plane و they form what looks like a square. طيب، حكيتي سس، okay? و if you recall حكينا انه في البداية it's actually the cisplatin is the one that is active. The trans لو طلبت منكم ترسموا الترانسبلاتين شو بتغيروا؟ Yeah, بعمل switch ما بين chloride و NH3, like giving rise, let's say, to this one in here. Why do you think the transplatin is inactive? Yes, only the chloride can live in this manner. هلا for this one يعني لو افترضت انه for instance this is the DNA strand, this is the one that will be substituted طبعا after being equated. فممكن يعمل a coordination bond مع DNA strand لكن وحده. Okay, still, even though if you think that, for instance, what about this chloride, can it, let's say, form a covalent bond مع another nucleic base من another strand, this is still far away. يعني لو البلاتينum عملت coordination with one nucleic base from this strand, this one is still far away إنها تعمل, let's say, replacement of this chloride. It will be only able to form one coordination bond, which is a weak complex. حتى لو تكون برجعوا بينكسر. Okay, that is why cis is inactive. Trans is inactive. كويس مركزين يعني. Thank you. طيب, so again, the molecule should be uncharged. Why do you think that? Yeah, so that it needs to be able to cross the cell. And after, let's say, crossing the cell with a صار له equation where it will have a charge, it will be trapped inside. If I already developed a platinum-based anti-cancer where it will have a charge, it will not be able to cross the cell membrane. And again, in terms of the group or what I can substitute the chloride with, it needs to be moderately strongly bound. Okay? طيب تفضل. هلا this is a very, let's say, أو خلينا نحكي a generalized statement. أنا مش بس can you rephrase it بس عشان أفهم أنت إيش قصدك؟ بدور على good living group. كوني لقيت good living group لا يعني إنه ممكن تتغير خالص مع بعض مصاديقها على المركب. تصير مثلا سامة أو تصير المركب صار سامة. For sure. هلا مثلا السيسبلاتين اذا انت بدك تبدله with a better leaving group, الكلورايدز with a better leaving group, for sure التوكسيسيتي راح تزيد للدرج. هلا let's say other examples او analogs that they've developed راح نشوف كيف مثلا بدلوا الكلورايد with a carboxylate. الكربوكسيليت مقارنه بالكلورايد يعني it's a good leaving group بس لسه يعني I wouldn't say أسوأ بس شويه الريت اوف its leaving بتكون ابطا من الكلورايد. هلا الاكتيفيتي بتقل بس مش لدرجه انه بصير الكومباوند inactive تماما والتوكسيسيتي بتقل. اوكي we'll see those examples later. طيب بس عشان ناكد على اخر جزئيه حكيناها انه we can alkylate النيتروجين لكن for sure الامونيا I would consider it يعني for pharmacokinetic, let's say, purposes. لكن no matter what, if I need to alkylate nitrogen, I need to at least leave an NH bond for the compound to be able to, let's say, form hydrogen bonding ويعمل لي stabilization للcomplex. طيب, here are, let's say, two examples of analogs that were based in terms of their design on cisplatin, الكاربوبلاتين والأوكزاليبلاتين. الكاربوبلاتين شو غيروه مقارنة بالسيس؟ leaving group. What is the leaving group in here? A carboxylate. Yes. Is it considered, let's say, a good leaving group? Yes, because when it leaves, that negative charge is stabilized via resonance. Okay. طبعا مقارنة بالكلورايد، يعني الكلورايد لأنه الباند is large. Okay, that is why it's weaker وممكن يطلع عندي بسهولة. هلا الكاربوكسيليت in terms أو relative to the chloride شوي أبطأ إنه تنكسر هاي الباند، شوي أبطأ. هلا this means إنه الactivity of this compound مقارنة بالسيسبلاتين راح تقل عندي. لكن at the same time السايد effects راح تقل. Why? Because when I lower the rate by which the equated form of this carboplatin formation, okay, معناها إنه أنا راح أقلل من هاي من the drug that will be interacting with off-target molecules such as the glutathione, such as مثلا السيرم albumin or any other protein موجود extracellularly أو intracellularly. Okay, فصح الاكتيفيتي عندي بتقل بس not to a point where I would consider الكاربوبلاتين completely inactive، بالعكس له therapeutic let's say activity for sure، لكن السايتوتوكسيسيتي بتقل عندي. هلا those let's say platinum based drugs السايتوتوكسيسيتي لهم results from انه الاكتيف فورم او البايو اكتيف فورم interacts مثلا مع الجلوتاثيون depleting الجلوتاثيون leading for instance to interaction مع many proteins. فأنا لما بدلت الكلورايد with carboxylate the rate by which the equated form forms where this will be substituted by water which will interact eventually with the DNA or any other target بتقل. بتقل معناها number of molecules that will interact with off-target molecules such as serum albumin, glutathione and so on بتقل. فذات is why السايتوتوكسيسيتي عندي بتقل او السايد افكتس خلينا بتقل. خلينا نحكي بتقل. الكاربوبلاتين relative to cisplatin is more tolerated by patients لانه الاكتيفيتي او السايتوتوكسيسيتي عندي اقل. الاوكزاليبلاتين what changes have they made on the structure? Still I have carboxylates bound to the platinum and as you can see they've alkylated let's say this nitrogen. طبعا for the purpose of enhancing pharmacokinetic properties. الاوكزاليبلاتين زي الكاربوبلاتين مقارنة بالسيسبلاتين less active okay slightly less active والسايد effects عندي كمان أقل. هلا معلومة هيك إضافية بس مش مطلوبة منكم. If you would refer to literature الأوكزاليبلاتين does not have cross resistance مع السيسبلاتين ومع الكاربوبلاتين. يعني الكاربوبلاتين usually الريزيستنس اللي بتصير against it is similar to that of cisplatin. لكن الأوكزاليبلاتين is not. ف they presume إنه الأوكزاليبلاتين بيشتغل via mechanisms other than interacting with the DNA. بس لأنه هاي الميكانيزمز مش well established فعشان هيك احنا مش رح نذكرها هون. But this is what is presumed. It also has mechanisms or ways of let's say the cytotoxicity that it produces other than interacting with the DNA. Okay? Yes. Yes. هلا بدنا ننتقل ل completely different drug let's say classes واللي هم الانتي ميتابولايتس. Okay? هلا so far احنا اللي حكينا عنهم those that can interact with DNA, alkylate with DNA. لكن this class that we will let's say be talking about now are those which we consider or we call الانتي metabolites. ليش بنسميهم anti metabolites؟ او هل هالترم مر عليكم before؟ For sure, yes. In particular, those enzymes which are involved in cancer metabolism. Okay? هلا تقريبا من 100 سنة they recognized إنه مش بس replication والtranscription بالcancerous cells بيكون different عن الnormal cells. They also identified إنه even metabolism itself is different. في كثير variations بالmetabolism ما بين let's say cancerous cells والnormal cells. In particular those metabolic pathways اللي بتوفر للسيل الانرجي that it needs, the precursors needed for let's say اللي بتحتاجها حتى مثلا تصنع الدي ان اي والار ان اي, and also الميتابوليك pathways او خلينا نحكي الانزيم نتوركس اللي بتقلل من الرياكتيف اوكسجين سبيشيز, لانه الرياكتيف اوكسجين سبيشيز في الكانسر سيلز بتكون let's say انتاجها بشكل كثير اكبر. اوكي, ف knowing this is what gave them let's say the خلينا نحكي ال perception انه if I او انه targeting the metabolism of cancerous cells is a very good approach for treating the cancerous cells selectively. Okay, so this is what we will be talking about. خلينا نحكي المحاضرة هاي والمحاضرة الجاية إن شاء الله رح نحكي عن those drugs which were developed and designed to inhibit enzymes involved in cancer metabolism. صح بعديها يعني with the let's say approval of some anti-metabolites بعدين صار pharmaceutical companies وجهت كل اهتمامها ل what we call اللي هم الكاينيز inhibitors اللي برضه رح نشرح عنهم بالتفصيل المحاضرات اللي جاي. لكن هلا if you would go back to literature كثير صاير في interest كبير بالكانسر ميتابوليزم لانه they have let's say many studies linking الكانسر ميتابوليزم مع let's say الابوبتوسيس والproliferation of cancerous cells. اوكي, طيب هلا those anti-metabolites رح نحكي فقط اليوم عن اول واحد وهيك ان شاء الله بنكون ماشيين مع الشعب اللي قبلكم على اساس اذا في let's say اي missing لاي ليكتشر بالفيوتشر يكون في مجال let's say ان يعني تكون خلينا نحكي التسجيلات متساويه بين الجميع. اول انزيم رح نحكي عنه اللي هو الداي هيدروفوليت ريدكتيز. اوكي, طيب من اسمه always link الانفورميشن والتيرمز, هاي كثير بتسهل عليكم تحفظوا وتربطوا. طيب dihydrofolate reductase, what do you think this enzyme does? Reduces the dihydrofolate. طب dihydrofolate comes from what you think? أو dihydrofolic acid comes from what? هو this compound comes you think from what? أو can be generated from what? من الفوليك acid, okay, which is, do we synthesize the folic acid? No, we get the folic acid from diet. طب what is the substrate of this enzyme? Dihydrofolate, okay, أو dihydrofolic acid. طيب look at the structure of dihydrofolate, sorry, الفوليك acid. وباي ذا واي لما نحكي احنا folic acid وfolate, what is the difference between them? Yeah, we are talking about the same exact compound like in different ionization forms. Folic acid for sure, this compound has an ionizable group. Acidic ولا basic? أكيد acidic, okay? والfolate لما أحكي folate, that's the ionized form where it is deprotonated أو البروتون اللي على الأcidic functionality is removed, okay? فعشان هيك don't mix أو يعني you need to understand when we say folate أو folic acid أو folate different ionization forms بس احنا بنحكي عن the same exact compound. طب what is the acidic functionality in folic acid? Look at its structure.
Carboxylic acid.
Yes, تمام. So it's the carboxylic acid. So this group in here اللي لو رجعت ورسمتها بشكل صحيح, okay, that's the form of, let's say, carboxylic acid. And I have two carboxylic acid functionalities in here. Okay? Does this structure remind you of anything? It's an amino acid. Glutamic acid, actually. Yes, it's a glutamic acid. طيب, هلا الفوليك acid, do you think it can be easily absorbed from the GIT? ممكن, yeah, that's a good, let's say, rationale أو خلينا نحكي thinking. But actually, folic acid, what they know is that it cannot cross easily a cell membrane. So that is why it needs to be actively transported through the cell membrane, or even let's say inside the cells, there are specific proteins or carrier proteins that, let's say, delivers it to the cells. طيب, هلا الفolic acid, when taken, by, let's say, the action of dihydrofolate reductase, it will be reduced into dihydrofolate and later to tetrahydrofolate. Look at the structures. Tell me what is the difference between them. Yes. Yep. لما احكي dihydro معناها relative to الفوليك acid, this compound has a hydrogen molecule add to it. And in particular, this bond in here is the one that gets first hydrogenated. Okay. طبعا تنسوش انه I have now 2 hydrogens in here and a hydrogen. So those 2 extra ones in the form of hydrogen gas were added to dihydrofolate. Okay? Oh, a hydride and a proton. With tetrahydrofolate, yeah, that second bond gets, let's say, reduced. تمام؟ طيب. هلا we need, let's say, to understand the importance of this enzyme حتى نعرف ليش why it was a very interesting, intriguing target to design inhibitors for it. هلا الدايهيدرو أو الفوليك acid, when, let's say, inside the cells or when it binds to dihydrofolate reductase, it reduces it to dihydrofolate. And then dihydrofolate, by the action of the same enzyme, then reduces the dihydrofolate into tetrahydrofolate. Okay? هلا tetrahydrofolate is converted to many cofactors later on. One of them, which is very, very important, is called 5,10-methylene THF. حتى تحفظوا this cofactor, which is very important later on, رح نحكي عنه برضو كمان بالتفصيل. لما احكي 5,10-methylene THF relative to THF, okay, there is a methylene carbon or a methylene group that was added to the compound connecting nitrogen 5 and nitrogen 10. That is why we call it 5,10-methylene THF. هلا where this cofactor gets its carbon, it gets it from serine by the action of this enzyme. Don't worry about this step. مش ضروري انكم تعرفوها وتعرفوا انه source of that carbon comes from serine or this is the enzyme that does so. Don't worry about it. Okay? What matters to you is that the THF can be easily, or it is converted to many cofactors. One of those is 5,10-methylene THF. The 5,10-methylene THF يعتبر a very important source of a carbon لأي process تحتاج carbon. لأي metabolic pathway بتحتاج carbon. This is the cofactor اللي الانزيمز بتعتمد عليه عشان تاخذ هاي الكربون وتضيفها to whatever it needs to add the carbon to. Examples, for instance, the conversion of deoxyuridine monophosphate into deoxythiamine monophosphate, which is a very important precursor for the synthesis of DNA. Okay? وبيكون احتياج الكانسر cells له بشكل كبير مقارنة بالnormal cells. This process, which is catalyzed by this enzyme, ورح نحكي عنه later on عن, let's say, a very important inhibitor of this enzyme. هالانزيم من وين بياخذ هالكربون اللي بيضيفها على اليوراسيل؟ From 5,10-methylene THF. All right? This is an example of one pathway that requires a methyl or a carbon, and this cofactor is the one that this enzyme gets the carbon from and adds it to مثلا اليوراسيل حتى يحوله للثيامين. Okay? بمعنى if I would inhibit this enzyme, this means إنه I would be inhibiting the synthesis of THF. I would be inhibiting the synthesis of methylene THF. بمعنى هالكوفاكتور ما راح يكون available حتى مثلا يحول لي اليوراسيل into thiamine. وconsequently I would be inhibiting DNA synthesis. Okay? طيب. Knowing this, لو أنا بدي أفكر okay, to design an inhibitor of this enzyme, من وين فكركم ممكن أبلش؟ Folate, من substrate itself. That's, let's say, the most common approach for designing drugs, إنه to start from the substrate itself. أعمل few structural modifications، أشوف هاي المodifications eventually شو بتعطيني. Okay? or if they are able to inhibit the enzyme ولا لا. And this is what they actually did. They based their design on folic acid structure, and they've came up with aminopterin, okay, which now is substituted by methotrexate. Look at the two structures or the three structures of folic acid, aminopterin, or methotrexate, and tell me what changes they've made on the structure of folic acid. This is a dietary supplement. Those are anti-cancers. What changes have they made on the structure? Okay, so one thing is that they've substituted this group, which is called what? Al-amide group with, do you know what we call this? Amide? لا. It's amidine. It's called amidine. Okay? الامidine relative to an amide more basic ولا less basic؟ هو اصلا الامide to begin with we do not consider it basic لانه simply a lone pair of electrons on the nitrogen are drawn inductively and by resonance from this carbonyl. فعشان هيك الالكترون density على هاي النيتروجين very low. احنا ما بنعتبر النيتروجين basic at all بالamides. لكن if you substitute الcarbonyl with an NH2 giving rise to amidine, هل الامidine now becomes basic? Yes, it's even more basic than aliphatic amines. Way more basic. Yes, but for this one, أنا عندي nitrogen here is actually, before I ask that, which nitrogens in here are more basic? Is it the primary nitrogen or this nitrogen that is part of this ring? Yes.
Part of this ring.
Yes. طبعا in this tautomeric form, by the way, يعني في عندي another tautomeric form, يعني you can consider in almost those two nitrogens يعني لا بما انها صارت part of this ring it's different. يعني انا بقصد مثلا في حالة مثلا for this one يعني if I يعني ignore what I'm saying بس أنا بدي أوضحه عشان هيك I won't be confusing you. ال other tautomeric form اللي أنا بحكي عنه is this one. Okay. Where you would have a rearrangement of a proton with double bond. يعني usually الأميدين معلش خليني بس أطلع شوي عن الموضوع. الأميدين على سبيل المثال it can be drawn in those two structures or in those two, let's say, forms. Those two are called tautomers. لو مثلا بدنا نسأل which nitrogen is more basic, in this tautomeric form it will be this one. In this tautomeric form it will be this one. Okay? Due طبعا to resonance. لكن لأنه في بيناتهم tautomerism, I would consider, let's say, the two nitrogens, they are equally present in solution. I would consider the two nitrogens having equal basicity. Like in this form, okay, this nitrogen is the one that is way more basic than this one. لأنه لو بدي أفكر بالother tautomeric form, I will be deriving this compound from being aromatic. فالequilibrium between those two راح يكون way more toward this form versus this form. Okay? Back to our what we have, let's say, considered. In this form, or this structure as it drawn, this nitrogen is the one that is way more basic. هل هي النيتروجين الوحيد البيسك بالستركتشر؟
لا.
Yes, تفضلي. Let's number this 1 and 2 and 3 and 4, 3, okay? Because similar to this one, I have also this nitrogen that can donate electrons via resonance. وبرضه كمان this nitrogen its donation of electrons can reach all the way to nitrogen number 3. This compound, if it is in solution, nitrogen 3 is the one that is most probably that will be protonated. Okay? طيب. Let's look now at how such a change زاد أو خلى هال two compounds يعتبروا inhibitors of the enzyme versus الفوليك acid. فبدي أفرجيكم هل let's say الimage which represents the interaction اللي بيعملها الفوليك acid and those drugs that have this ring system اللي احنا بنسميه الامينوبتيريدين. Okay, to look at how and why binding affinity صارت بشكل كبير and why this compound now is considered an inhibitor of the enzyme. بس الانفورميشن والديتيلز اللي راح احكيها مش مطالبين فيها بشكل كبير. Okay, طيب to keep in track in this image, here is the ring. بحالة الفوليك acid this is the amide, right? وخليني أرقم الكاربونز. This is 1, this is nitrogen 2, this is carbon 3, nitrogen 4. Okay? يعني الترقيم اللي أنا بستخدمه مش هو الcommon numbering اللي حكينا عنه before, بس just to keep in track. So here is the carbon 1, nitrogen 2, carbon 3, nitrogen 4. طيب. Nitrogen 2. What kind of interaction it's forming with the amino acids اللي موجودين في الactive site of dihydrofolate reductase? Hydrogen bond interaction?
Ion dipole.
Yes, it's an ion dipole interaction. طبعا it's a very strong kind of a hydrogen bond. تمام? Look at this nitrogen in here. It is forming also a hydrogen bond. طيب لو هلا بدي اطلع على those drugs الامينوبتيرين الميثوتريكسate with the change in structure that we did. This is nitrogen أو خلينا نحكي carbon of the amidine, nitrogen 2, carbon 3, nitrogen 4. يعني I made this one highly resembles this one. يعني those two images just show you إنه الفوليت محل ما بيرتبط لو أنا بدي أبدل الأمينوبتيرين أو أبدله بأمينوبتيرين أو ميثوتريكسate بصير في flip للرينج. تمام؟ So this is carbon 1, nitrogen 2, carbon 3, nitrogen 4. Okay, وكأنه صار في rotation للring system, للبتيريدين ring system. طيب still nitrogen 4 اللي كانت هون ما بتعمل any interaction هلا عم تعمل still what kind of interaction with this aspartate?
Ionic interaction.
Ion dipole interaction. هل برأيكم هل ion dipole interaction is stronger or weaker than this ion dipole interaction? Much stronger. ليش? Yes, because this nitrogen is positively charged. الهيدروجين nitrogen bond is very polarized. partial positive charge اللي على البروتون بتكون very high, which means إنه such an interaction راح يكون much stronger. Okay, ولاحظوا أنا عندي النيتروجين أو الكربون 1 النيتروجين اللي عليها is forming 2 hydrogen bond rather than having just 1 hydrogen bond in here. فالbinding affinity إنه صارت عندي الinteractions more. The strength of the interactions that the drug forms with the enzyme is way more. The difference في pKa ما بين الفوليك أسيد والميثوتريكسate والأمينوبتيرين تقريبا pKa the difference ما بينهم almost 2 والbinding affinity as for 3 الbinding affinity seen for this compound almost 3 أو 10 to the power of 3. Okay? يعني تقريبا الديفرنس ما بين pKa which is لما نحكي طبعا احنا 3 احنا بنحكي عن order of magnitude of 3 يعني acidity of basicity of aminopterin والميثوتريكسate مقارنة بالفوليك أسيد 1000 مرة أكثر والbinding affinity زادت برضه almost 1000 مرة. Ionic interaction. Actually, this nitrogen will be protonated at physiological pH. pKa لها كثير عالية. هلا لو كان ما بين النيتروجين وما بين الاكسجين والنيتروجين ما في عليها او يعني يعني the one that is actually forming interaction مع الهيدروجين مش النيتروجين، لا ما بنعتبرها انه ionic interaction. It's an ion dipole interaction. لكن still this interaction بيكون very 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 strong. وديفنتلي ممكن يكون في عندي slight let's say electrostatic attraction ما بين النيتروجين وما بين الاكسجين. Yes. It wouldn't make much difference. يعني لو خليتيها مثلا resembling الفوليك acid أو resembling الدايهيدروفوليت it wouldn't make much difference in terms of the changing الform سواء كان oxidized أو reduced. What made a difference إنه أنا غيرت ال pKa بدلت الأميد with an amidine زادت عندي البيسيسيتي تقريبا 1000 مرة ومقابلها زادت البايندينج affinity almost 1000 مرة. Which means إنه these drugs when binding to dihydrofolate reductase they will prevent the binding of folic acid و dihydrofolate, which means إنه ما راح يتكون عندي THF ولا راح يتكون عندي ال 5-10 methylene THF. فبالتالي هاي sources أو this cofactor eventually its depletion will deplete the synthesis of thiamine and eventually will prevent أو lower أو خلينا نحكي almost will inhibit the DNA synthesis. Okay. طيب هلا the reason why الميثوتريكسات والامينوبتيرين also other forms of the let's say analogs of dihydrofolate reductase why they are selective to cancerous cells versus the normal cells, the explanation for that is that الميثوتريكسات مثلا اوكي وزي طبعا زي الامينوبتيرين كمان نفس الشيء. These drugs when they enter السيلز بصير لهم what is known as polyglutamation. هلا مش بالstructure in here we have a glutamic acid part. What happens inside the cells is that some enzymes are actually adding glutamic acid to the glutamate, leading to polymerization of this segment, which means إنه the polyglutamate form of methotrexate will become larger and larger, and because of وهاي طبعا بيكون polarized, and because of the large size, because of the very high polarity, it will be trapped inside the cells. Okay, هلا this process of polyglutamation بتكون much more rate for it, way much more بالcancerous cells versus in normal cells. So that is why, or this is what adds to the selectivity of methotrexate with aminopterin for cancerous cells. Okay. There are other examples of analogs which were based on the folic acid also, الpimetrexate والpralitrexate acid. Okay. The variations mostly that they've done is they've removed the amino group in here because they found out in مثلا الامينوبتيرين in terms of the side effects, in terms of the cytotoxicity associated with it, it's less than methotrexate because the cells can recognize the NH group. أنا حكيت لا هي actually more side effects of aminopterin more than الميثوترexate. So because cells can let's say recognize the NH group, so they found or they thought or they rationalized إنه لو شلت كل ال N group تماما راح أقلل من ال entrance of those drugs into let's say normal cells. Any questions so far? طيب راح نوقف هون والأسبوع الجاي أو أسف المحاضرة الجاية بنكمل عن the rest of the antimetabolites. هلا البايندينج affinity يعني it's not attributed to the خلينا نحكي ال basicity of that compound or the basicity of those rings. This ring when it binds to the drug it forms more acid, to the enzyme it forms more interactions. ال binding mode يختلف, الانتراكشنز اللي بتعملها بتكون عندي أقوى وبتختلف. احنا يعني فقط ركزوا على الميثوتريكسيت والامينوبتيرين versus الفوليك اسيد. لكن البراليتريكسيت البيمتريكسيت او اسف التريكسيد those ones الرينجز بيرتبطوا بطريقه مختلفه، والبايندينج افينيتي بتكون بشكل افضل مقارنه بالفوليك اسيد due to different interactions. احنا مش رح نركز عليهم او مش رح نحكي عنهم، احنا فقط رح ركزنا على الميثوتريكسيت so only worry about الميثوتريكسيت. any question؟ طيب اللي موجودين اونلاين يا جماعه في حدا عنده اي سؤال؟
يعطيك العافية دكتورة.
الله يعافيك.